ওকে, ওয়ালাইকুম আসসালাম। দেখতে পাচ্ছ 17 নম্বর প্রশ্নটা করব। কোয়েশ্চেনটা দেওয়া ছিল ইন ট্রায়াঙ্গেল এবিসি এ ইজ এ রাইট অ্যাঙ্গেল। ইন ট্রায়াঙ্গেল এবিসি এ ইজ এ রাইট অ্যাঙ্গেল and BP and CQ are two medians. BP and CQ are two medians. They are two medians, meaning that Q divides AB into two pieces. Q divides AB into two pieces and P divides AC into two equal pieces. That is, we can say that AQ is equal to PQ from here, and P is the midpoint, meaning that CP is equal to AP. So AP equal to CP. And then we have to prove that 5BC square equal to 4 BP square plus CQ square in the bracket. ওকে, এটা আমরা হচ্ছে এখন প্রুফ করব। তো কোয়েশ্চেন বোঝা গেছে নাকি? ওকে, প্রথমে আমরা হচ্ছে এ বিপি ট্রায়াঙ্গেল নিলাম। এবিপি ABP is a right angle triangle, right? This is a right angle triangle because angle A is 90 degree. They have given angle A to be equal to 90 degrees. So this is a right angle triangle. So if this is a right angle triangle, we can use Pythagorean theorem, that is BP square is equal to AB square plus AP square. AB square plus AP square. Now let's take another right angle, that is ACQ or AQC. In triangle AQC, angle A is 90 degree. Angle A is 90 degree. So again we can use Pythagorean theorem, that is hypotenuse square, hypotenuse is CQ square is equal to AQ square plus AC square. And we have another triangle, another right angle triangle, that is ABC. We have this right angle triangle ABC. So let's write triangle ABC. Here A is 90 degree, meaning that this is a right angle triangle. So from here we can write that hypotenuse, which is BC, hypotenuse square is equal to this two sides squared, and then take the sum of them, that is BC square equal to AB square plus AC square. So first things first, let me give you a brief what I have done here. I took the first right angle triangle, which is ABP, and I used the Pythagorean theorem. Then I took AQC, another right angle triangle. I used the Pythagorean theorem again. And then in right angle triangle ABC, we have used the Pythagorean theorem once again. Hence, we have found these three equations. Let's call this equation number 1, this is equation number 2, and this to be equation number 3. Okay. Now we have to find out 5BC square is equal to 4BP square plus CQ square. So there is your BP and CQ. right? BP and CQ is here. So why don't we write the right hand side? And from the right hand side, we will prove the left hand side, okay? So from the right hand side, we will prove the left hand side. Let's write the right hand side first. So we have right hand side equal to BP square plus CQ square multiplied with 4. So BP square is equal to this, AB square plus AP square. BP square is equal to AB square plus AP square. How about CQ square? CQ square is equal to this AQ square plus AC square. So this is AQ square plus AC square. Well, now let's take AB and AC together. Let's take AB and AC together. So 4 times AB square plus AC square, and then take this AP and AQ together. AP and AQ together. So this is 4 times AP square plus AQ square. So remember what we need? We need a BC square on the right hand side, sorry, on the left hand side. So I have AB square plus AC square. So AB square plus AC square, AB square plus AC square is equal to BC square according to equation number 3. So this is BC square according to equation number 3. AB square plus AC square equal to BC square. Now for the next part, we have AP square plus AQ square. So AP square plus AQ square, right? But we need BC. So I can do one thing for sure, that is we can write AP is equal to half of AC, because AP and CP are equal parts, they are equal amounts. So instead of AP, you can write half of AC, and there is this square here. I introduce a second bracket. And how about AQ? We can write AQ is equal to half of AB, because AQ and BQ both are equal. So we can write AQ to be half of AB. AQ is half of AB. And there is this second bracket that we should close. Well, we have 4 BC square, and then I have this half of AC squared, meaning half square will be 1/4, and then I have AC square this is AC square, and then from here I have another 1/4 which I took as a common quantity. So I have AB square. So now these 4 cancel each other, these 2 4s are going to be cancelled. We have AC square plus AB square. So AC square plus AB square according to equation number 3 is BC square. This is nothing but BC square, right? So let's write BC square instead of AC square plus AB square. So I have 4 BC square. I have 4 BC square here. and I have AC square plus AB square equals to BC square. Hence, 4 BC square plus 1 BC square gives me 5 BC square. That is the left hand side that we have to prove. So we could have started from left hand side. We could have started from left hand side, and then using equation 1 and 2, we could have reached to the right hand side. But taking the right hand side first and proving the left hand side is easier in my perspective. So you can do however you want to do. Do you have any question? So you have to practice a lot. These are theorems. You have to do them, practice them without seeing your answer or your notes, even your guides. Other than that, you will not be able to do that in your exams. Theorems are always difficult when it comes to doing it in exams. Okay, let's do another one from this chapter. We are done with 17. Let's do 21 probably, right? 21, right? Let's do 21. Theorem number 21. Do you hear any noise? Like, do you hear any background noise while you listening to my? Okay, so question number 21. 21, right? Well, so the question is, in triangle ABC, we have A equal to one right angle and D is a point on AC. D is a point on AC. So let's draw the figure. We have a triangle with an right angle triangle, that is A, that is the right angle triangle. So let's consider this to be B and C. So we have this triangle ABC, of which angle A is the right angle and D is on the line AC. D is a point on AC, right? So this is AC. D is somewhere here. Okay, so D is somewhere here. It's not necessary to D to be in the middle of AC. Okay, it can be anywhere from A to C. So I've just considered D to be anywhere. It doesn't represent actually the half of the AC. Okay, it doesn't represent half of AC. It could be anywhere. It could be here, here. Now we gotta prove this to be equal to that. Okay, let's start. Before starting, we have to draw a line joining these 2 points B and D. Well, we join these 2 points because you can see in your proof you have BD. You have BD. So it's saying that you should actually join B and C points. So you have to actually mention that joining B comma D, we get BD. Now for the proof, so you see in triangle ABC we have A which is equal to 90 degrees. So A is 90 degrees, that is given. So we can say from here that BC square is equal to AC square plus AB square. So BC square, which is the hypotenuse square, is equal to these 2 other sides square. So this is from Pythagorean theorem. You should mention that in the brackets. So you have this first equation. This is the first equation. Now for the second equation, we take ABD. We take the triangle ABD, and here angle A is 90 degree. Angle A is 90 degree, meaning that this is also a right angle triangle. So we can use Pythagorean theorem, that is BD square is equal to AD square plus AB square. So BD square equal to AB square plus AD square. BD square equal to AB square plus AD square. So this is going to be equation number 2. This is our equation number 2. Okay, so let's write the left hand side. Left hand side is given to be BC square plus AD square. So BC square is basically this. BC square is equal to AB square plus AC square. So BC square equal to AB square plus AC square from the equation number 1. Right, this is from equation 1. And AD square, the value of AD square can be found out from equation number 2. AD square can be written as BD square minus AB square. So it will be BD square minus AB square. BD square minus AB square, that is from equation number 2. So I have taken the value of BC square from equation number 1 and AD square from equation number 2. I have just rearranged it. So AD square will become BD square minus AB square. So now we have to prove this. We have BD square, but we will need only AC square. You have AB square minus AB square cancelling each other. Therefore, now you have BD square plus this AC square, and that is the right hand side of this theorem, and hence this theorem is proved. This is 21 number question of your book. So I believe in the similar fashion you can do 22 number question. And probably also 23, because they all are quite same. I mean, of course, all of them uses Pythagorean theorem, but also the logic that goes behind 23 number question is same as 21 number question. So let's do the last one, that is 24, question number 24. Okay, so question number 24. In triangle ABC, AD is AD is the perpendicular to BC, and P is any point on AD, and AB is greater than AC. AB is greater than AC. Now prove that PB square minus PC square is equal to AB square minus AC square. See if I made any mistake. I hope not. Okay, so looks to me that I have written down the question correctly. So now it's time to draw the figure. So we have a triangle ABC, and AD is perpendicular to BC. So AD is perpendicular to BC means that, let me use a different color, means that you take a perpendicular from A to BC, and this is D. So this is perpendicular, meaning that this is 90 degrees. Now P is any point on AD. P is any point on AD. Okay, let us consider this point to be P. So remember, P is any point, meaning that P could be anywhere on this line. And then AB is greater than AC. Does it look like AB is greater than AC? Perhaps not. But anyway, you have to think that this side AB is definitely greater than AC. AB is greater than AC. So let's just for a moment we keep that in our head, in our brain. Okay, prove that PV square minus PC square is equal to AB square minus AC square. So where do we start? Do we start from the left hand side or right hand side? Well, we will do that, but first things first, we will draw two lines joining B and P. So the first line will be BP. BP stands for blood pressure. That is blood pressure. And then PC stands for personal computer, right? Okay, so you have to definitely mention that join B comma P and B comma C. Now for the proof, we have triangle ABC, and in triangle ABC they have said that AD is perpendicular to BC, right? AD is perpendicular to BC. This is perpendicular sine. AD is perpendicular to BC. So I take the first triangle, that is ABD. So first triangle is ABD, and then we have ACD, and then we have BPD. All of these triangles are right angle triangle, right? So this is ABD and then ACD, triangle ACD and BPD. All of them are right angle triangle. Right angle triangle meaning that at least one of the angles are 90 degrees. Only one angle is 90 degree. Right angle triangle. Right angle triangle. Okay. So from triangle ABD, you can say that AB square. You can say that AB square is equal to BD square plus AD square. So in triangle ABD, you can say the hypotenuse square, that is AB square, is equal to BD square plus AD square. We have been using Pythagorean theorem in all of our problems in this chapter, hence the name Pythagorean theorem. So this is the first equation. Let's write equation number 1. Now let's take triangle ACD. So first we took ABD, then we take ACD. So in triangle ACD, we have AC square equal to CD square plus AD square. I understand that you know all of this. This is a very easy thing, right? This is easy for you because we are using only Pythagorean theorem. But the real challenge goes into understanding the approach of each of these problems when you get the exam, when you sit for the exam. So for that you have to practice a lot to remember which maths to do in which method. My goal is to make you understand these topics. Now the last triangle BPD. In triangle BPD, so in BPD, BP is BP is hypotenuse. So I will write PV, okay, not BP. PV because I have PV here, not BP. So PV square is equal to BD square plus BD square plus PD square. This is equation number 3. So we have 3 equations. For 3 triangles. We have triangle ABD, then triangle ACD, then triangle BPD. Well, we will consider another triangle, that is PCD. We have considered BPD and also we'll consider this PCD. So we have basically 4 right angle triangle. First one is ABD and then ADC, then BPD, and here we have PCD. So we will consider all of those triangles. Now we have PCD. In triangle PCD, I have PC square equal to CD square plus PD square. Again, same Pythagorean theorem, should be very easy for you. So we are almost done. We are almost near to the end of the problem. That is, you take the left hand side. Let's write the left hand side first, okay? Then from the left hand side we should be able to find the right hand side. Let's write left hand side. Left hand side equal to PV square minus PC square. PV square minus PC square, okay? So PV square is this thing right here. We have BD square plus PD square, and then PC square is this, that is CD square plus PD square. Okay, so if I remove the bracket, I have this, and PD square will cancel each other, giving us only BD square minus CD square. So let's remove this. We will have BD square minus CD square from here. So we have BD square minus CD square. So our left hand side is this, but our right hand side does not match. So we would have to use equation 1 and 2, equation 1 and 2, in order for these two match. These two match the result, match the right hand side. So how can we do it? We plug in the value of BD square from equation number 1. BD square is AB square minus AD square. So BD square is basically AB square minus AD square. So definitely use side notes. In the side notes you write from 1, okay, and then we will also take CD square from equation number 2. CD square is AC square minus AD square. So this is AC square minus AD square. So we are very close to the end of this math. So if I remove the bracket, I have a plus sign here. Now for that, I have plus AD square minus AD square cancelling each other out. AB square minus AC square. That is the right hand side. Hence, this theorem is proved. What do you think? Was that a tough one or easy one? Okay. It's very easy because first we took these four triangles, four right angle triangles. We took A, D, B, and then we took A, C, D, and I used Pythagorean theorem. And then I have B, P, D, and P, C, D. Using Pythagorean theorem, we have four equations. Then from the left hand side, you could have also started from right hand side, and you would be ending up on the left hand side. So then I took the left hand side. After some algebraic manipulation, I got the right hand side. So as I was saying, that the real challenge is not to understand this chapter, because this chapter, the concept is very easy to grasp for any student, but the real challenge is to remember in the exam that which method goes into which maths. So that would be it from this chapter. This was the last question that actually concludes this chapter. Oh, I have another problem. 19, question number 19. Okay, so that's your homework, question number 19. If you face any problem, make sure you let me know. Make sure you tell me about that. Question number 19 is your homework from this chapter. And that would be the end of this session. In the next session, we will be talking about chapter number 13, I guess, right? Chapter 13. So